So for the class, our topic will be about Module 3. So basically, it's all about solubility and distribution phenomena. So actually, this is just one topic for Module 3. Okay, after this class, we will be discussing qualitative properties of your solutions. Okay, so basically, what are the effects when you add solute to a solution? Okay, what happens to their physical properties, basically. Okay, so pero first and foremost, class, this is just the first part for Module 3. Second part, we'll be talking more about electrolytes naman. Okay, and how pH basically affects, again, solubility pa rin of our solutes in a solvent, in a given solvent. So class, our objectives for today, of course, would be for us to understand how solubility works. Okay, how does a solute affect the physical properties of the entire solution, okay, afterwards, and how do solutes behave once they are inside in a solution. Okay, so as you all know, class, we have different types of solutions. We have homogeneous mixtures, okay, we have heterogeneous mixtures. Okay, pero of course, class, in terms of pharmacy, ang goal lagi natin, class, gumawa ng isang homogeneous mixture. Because homogeneous mixtures, class, okay, are pretty much aesthetically pleasing. Okay, mas magandang tingnan pag homogeneous ang mixture mo. So I think alam niyo naman ang ibig sabihin pag sinabi natin homogeneous, right? Ibig sabihin, class, one phase lang. Okay, kahit na halo-halong, kahit kung ano-ano pinaghalo-halo na dyan, pag homogeneous yung itsura niya, okay, mas maganda siyang tingnan. Tingnan nyo na lang ka-suspension, right? A suspension, class, if it's not shaken, makikita mo yung layers, di ba ang pangit niyang tingnan? Eh parang, yun, may layers kasi siya, so hindi siya kaaya-ayang gamitin. At the same time, class, of course, ang mangyayari dito would be, pwedeng ma-underdose ang patient kasi hindi scattered all throughout the solution or mixture yung ating gamot. Okay? So that's the reason why, class, most homogeneous mixture, okay, or most of our solutions, we want it to be homogeneous as much as possible or clear. Okay? And with that, okay, let's proceed to our topic for today. So first and foremost, class, what's the significance of this topic? Okay, it permits a pharmacist to choose the best solvent medium of a drug, for a drug, or a combination of drugs. Now, class, one of the things that you will be learning for today's topic would be more on what's the best solvent para sa given solute ko. Okay, kasi nga, class, pag-uusapan natin dito is solubility. Aanhin mo, class, ang gamot kung hindi siya matutunaw sa vehicle or sa solvent na gagamitin mo. So I'll be teaching you guys how to identify kung saan pwedeng maging soluble ang isang solute based on, say, for example, well, the chemical structure. Okay? Tingnan mo lang yung structure, class, ng iyong gamot, pwede mo agad malaman, ay, maganda to for polar solvents or non-polar solvents. So how do I know kung polar ba ang gamot ko or non-polar? We actually had an earlier discussion about that, right? Okay, with our quiz yesterday. So one thing, class, na mapapansin mo for polar solutes would be mas defined, okay, yung kanilang charges. Kumbaga may dipole moment yung ating molecule. Ibig sabihin, class, defined yung negative charge at saka yung positive charge. Kasi for most non-polars, class, non-polar molecule, hindi ganun ka-define yung separation ng kanilang charges. Okay, wala siya tinatawag na dipole moment. Okay, kung saan, class, di ba sabi ng dipole moment, basta makikita mo talaga may slightly negative and slightly positive area dun sa molecule na yon, which makes them polar. Okay, kasi may positive, may negative charge. Of course, if you want to talk about real polar solutes, yun yung mga solutes na may ionic bond, syempre. Combination of metal and non-metal. Okay? So, yun. So, class, yun yung mga bagay-bagay na pag-aaralan natin dito. Okay? Then, of course, helps in overcoming certain difficulties in the preparation of pharmaceutical preparations or solutions. Okay, kasi, class, if you know the proper solvent na gagamit yung pantuna sa solute mo, hindi ka magkakaroon ng problema. Magiging homogeneous ang solution na magagawa mo. And can serve as a standard or test for purity. Okay, now that's that for solubility. Now, just a quick recap lang, class. I hope you still remember this. Okay, I think naalala niyo pa naman to, right? QC, tama? Expressions of concentration. So you have molarity, molality, parts by mass, parts by volume. Okay, then of course, mole fraction. Okay, so familiar nga ba? Tama nga ba? Okay, good. Kasi alam ko, gamit na gamit ito sa QC, quality control. So, halimbawa, pag molarity, it's just mole of your solute. So that's, if you still remember, class, mole is equal to weight over molecular weight or molar mass. Right? So usually this is gram per mole. Okay? So si molar mass natin. That's for moles. Ito yun. Na syempre, ang solution natin, okay, whatever volume. Normally, class, the what do you call this? The volume class should always be expressed as liters for molarity. Molality, on the other hand, similar to molarity, ano lang pinagkaiba? Okay, ang ating denominator class, instead of volume, okay, it's in mass. And that is class expressed in kilograms. Now, please take note, in molality, it's the kilogram of solvent, not the solution. Are we clear? Solvent. So, halimbawa, class, pag sinabi kong my solution weighs 1.2 kilograms. Kunwari. Tapos, ang aking solute weighs 200 grams. Okay, so anong class ang weight ng solvent? Okay, just looking at this class, you can already tell ano ang weight ng ating solvent. That will give you 1.2, so that's 1,200 grams. So, anong gagawin ko dito? So, dapat kasi gagawin lang nandito is weight of solution minus weight of solute. And that would give you weight of the solvent. And in this case, class, that's 1,200 grams minus 200 grams. That would give you 1,000 grams. So, are we clear? So, that's the weight of your solvent. Okay? Kasi class, ganito ang napapansin ko. Kasi nagtuturo ako ngayon ng PharmCal eh. Kaya napapansin ko yung mga estudyante ko, halimbawa, ibibigay ko sa kanila is ang weight ng solute. So, di ba, kung kukuha ka ng percent weight by weight, kailangan, class, ang weight na denominator mo is the weight of the solution. So, meaning you have to add pa the weight of the solute plus the weight of your solvent to get the weight of the solution, correct? Okay, so nangyayari sa kanila is, ginagamit nilang denominator is only the weight of the solvent, which is of course wrong. Okay, kasi class solvent lang yun, wala pa yung solute doon. Alright? So, halimbawa, yun nga, yung percent weight per volume, or weight per weight, halimbawa, ganyan. So, class, please remember this one, ha? Marami kasi ako mga estudyante, promise, ever since I started teaching, this is something that they always forget. Actually, ako rin naman, I'm a victim of this. Okay, when I was a student, hanggang ngayon, magtuturo ko, minsan, na-overlook ko pa rin to. Okay, pero always remember, class, for molality, it's the mass of your solvent. Solvent lang. Okay? Okay. So anyway, so parts by mass, so that's mass of solute over mass of solution, parts per volume, blah, blah, blah. Of course, class, then we have the mole fraction. Okay, for mole fraction, class, it simply talks about the mole of your solute. Okay, ano yung mole ng solute mo? Over the mole of your solute plus the mole of your solvent. So technically, this is the total mole of your solution. Okay? Pero class, para lang hindi tayo malito, so that's mole solute over mole solute plus mole of the solvent. So kung ang solvent mo is water, get the moles of your water. So obviously, meron ka na molecular weight, kailangan mo na lang would be yung kanyang weight. So that's weight over molecular weight or molar mass. Okay? The same goes with your solute. Okay? Kasi mamaya class, you'll realize may mga applications kasi yung mga expressions of concentrations na to when we start talking about colligative properties of your solutions. Okay, how does your solute affect the physical properties of the entire solution? Okay, and then of course other expressions includes mass percent, volume percent. Alam niyo na to, I'm pretty sure. Okay, so this is just a recap of the formulas we have. Now, let's talk about solubility, class. So sabi nga, class, by definition, is simply the concentration of solute in a saturated solution at a certain temperature. Now, the spontaneous interaction of two or more substances to form a homogeneous molecular dispersion. So meaning, class, when we say that a solute is soluble in a solvent, the solute can interact with the solvent, meaning it can bind to the solvent. There is may capacity siya to create bonds with the solvent. As you all know, class, marami tayong ways to create bonds, right? Of course, the easiest way is to create a van der Waals forces, okay, which we can easily manipulate. Okay, so ang kailangan lang naman dyan usually adjust temperature or adjust pressure. Okay, and of course can affect the formation of bonds between molecules. But of course, class, there are inherent characteristics of our molecules that can create bonds with our solvents. A very good example of that, class, would be, of course, hydrogen bonds. Okay, remember hydrogen bonds? It's a type of dipole-dipole bond. Okay, wherein, class, hydrogen natin connects with other electronegative molecules within the system, right? And of course, class, ang pinaka-popular na solvent na ginagamit natin that creates hydrogen bonds would of course be, yes, very good, that's water. Okay, yung water natin, right? So, to be more technical, class, how do we define solubility? So, it's the number of grams of the solute necessary to saturate 100 grams of the solvent at a certain temperature. Normally, class, ang temperature nandito would be, of course, standard room temp. Okay? So, as you all know, class, room temp can range between 20 to 25 degrees Celsius. Okay? Some reference would tell you 20 to 22 degrees Celsius. Okay lang din yun. Pero class, personally, okay, sa akin lang to, sa klase lang natin, ha? Right? I prefer, class, to use the, for room temp would be 25 degrees Celsius. Ito yung standard, madalas na gamitin natin sa Pilipinas. Okay? Ito yung kaya nating abutin na temperature, room temp, kapag naka-aircon yung kwarto natin. Right? So, yun yung usual na room temp na ginagamit natin. Alright? So, other definitions, class, that we have regarding solubility. So, we have here solvent. Okay? Siguro, alam niyo naman ng mga terms na to. Solvent, class, is the most abundant component in a given solution. So, kung ano yung pinakamarami, yun yung solvent mo. So, halimbawa, a combination of 10 grams of sugar. Okay, sugar plus 100 grams of water, obviously, sinong solvent ko? Okay, sino pinakamarami? Yes, Mr. Paula?
Water po.
Definitely, that will be my water. This will be my solvent. And what's the total weight of my solution? Anong total weight ng solution ko? Sorry, bakit ba pagkakasulat ko? That's 10 grams of sugar plus 100 grams of water.
110
okay,
grams.
Okay, very good. Diba? It's going to be 110. Okay, very good, Miss Conopio. Almira. Okay, that's 110 grams. That's the total weight of the solution. Pero kung ang tanong ko is solvent, alam mo, nagpapakumpita ako ng molality, okay, kailangan ng ilagay na denominator is 100 grams. Okay, ingat-ingat kayo sa mga ganun, ha? Alright? Ayan. So, that's a solvent. So, basically, class, ang solvent yung ginagamit pang tunaw. Ginagamit pang tunaw. It's the most abundant component in a given solution. What about solute, class? It's a component being dissolved in a solvent, obviously. Okay, and then solubility, class, simply refers to the maximum amount of solute that dissolves in a fixed quantity of solvent at a given temperature. Now, normally, class, yung temperature na yun would be 25 degrees Celsius, pero it depends. It depends, class, okay, kung ano ang sinasabi ng, kung anong temperature ang kailangan gamitin. Okay, pero again, kung hindi sinabi, standard would be 25 degrees Celsius here in the Philippines. Okay? Here in our scenario, okay? Sa ibang bansa, 20 degrees Celsius ang kanilang room temp. Siguro kasi malamig doon sa kanila. Right? So, kaya nilang ma-reach yun. So, class, again, dilute and concentrated solutions, these two terms, are usually what we call qualitative terms. Qualitative lang yan. Pag sinabi kong concentrated lang solution ko, ang ibig sabihin lang nun, marami yung solute. Okay? Or matapang yung concentration. Tama? Pag sinabi natin diluted, malabnaw. Okay? O hindi gaanong matapang. Okay, so those are qualitative terms. But if you want to quantify it, class, then obviously you have to use certain terms, appropriate terms, class, to define solubility. They usually expressed in Remington or USPNF, and we'll be talking about that in a while. Okay. Now, some things, class, that we have to other terms that we have to be familiar with. Okay, saturated, unsaturated, that's our supersaturated solutions. Now, class, ano ba ibig sabihin pag sinabi natin saturated ang isang solution? Okay? Pag sinabi natin ka saturated, ibig sabihin nito, yung maximum capacity ng solvent mo, okay, given a defined volume or amount of solvent, okay, may limit yung solvent na yon in terms of how much solute it can dissolve. Right? Once na-reach mo ang limit na yon, sakto ka doon sa limit na yon, we call class the solution as saturated. Okay? Ibig sabihin, sakto na. Yun, nag-record tayo. Okay. Sakto na yung amount of solute na kaya niyang i-dissolve nung solvent mo. Okay, at a specified temperature, pressure, and volume or amount of the solvent. Alright? Pag sinabi natin kasi unsaturated, ibig sabihin, hindi pa sapat. Okay? Ibig sabihin, kaya pang dagdagan ng solute kasi unsaturated pa yung solution ko. Okay? So, it's one containing the dissolved solute in a concentration below that necessary for complete saturation. Alright? Maliwanag ba tayo? Ibig sabihin, class, if I say, for example, I give you 100 ml of water. Okay, kunwari lang to, ha. Here's a glass. This contains 100 ml of water at 25 degrees Celsius. Sabi natin, sige, dagdag pa rin, at 1 atmosphere. Standard pressure and temperature of room temperature lang natin. Okay? So, 100 ml, gaano karami ang capacity niyang mag-dissolve ng solute? Kunwari lang naman, ang max capacity niya would be, in terms of solute, kunwari lang is 100 grams. Okay, so beyond 100 grams, Hindi niya na kayang i-dissolve. So, ano nangyayari sa solution natin? Makikita mo, class, mag-precipitate na lang yung solute natin. Sabihin natin sugar. Sugar tong solute natin. Okay, sabihin natin sugar. Okay? So, class, pag nilagyan ko ng 150 grams of sugar, yung 50 grams, class, makikita mo, magpe-precipitate yon sa tubig natin. Kasi na-reach ko na ang saturation point ng aking water, 100 ml. So, are we clear? Okay, so kung unsaturated yan, class, ibig sabihin, yung solute ko, hindi pa na-meet yung 100 grams. Yes, that's unsaturated or subsaturated solution. Obviously, class, pag sinabi natin supersaturated, what happens here? Yun na nga, is one that contains more than the dissolved solute that would normally contain at a definite temperature where the undissolved solute is present. Okay, so basically, class, pag supersaturated na yan, hindi na kayang tunawin nung solvent mo at a given volume, temperature, and pressure, okay, yung excess solute na gagamitin natin. So, maliwanag ba tayo doon? Okay. So, parang ganito, class, sayang, hindi natin ito magagawa na experiment because this is actually one of the experiments supposed to be for sa solutions. Okay? We're going to, class, create a saturated solution. Tapos, class, tingnan mo to, this one is a crystal seed. It's a seed of whatever solute you're using. Normally, ang ginagamit natin dito is tawas. Alum. Okay? So, class, isa-saturate natin yung water and tawas mixture. Okay, huwag kayo magkala, matutunan naman yung tawas sa tubig, usually. Okay, tapos, class, pag na-reach mo na yung saturation point niya, maglalagay ka ng isang kapiranggot lang na tawas. Okay, lagay ka ng kapiranggot na tawas, class, like this one. Yan. This is going to be already beyond the saturation point. Okay, this amount of solute will cause your, yung concentration ng tawas sa tubig natin to be oversaturated or supersaturated. Tapos, kasi magugulat ka, pag hinulog mo yan, mag-start na yan mag-form ng crystals. Magpo-precipitate na siya. Okay? So, this one, tawag yun is nucleation. Okay? It's a process wherein we create actually crystals or we purify crystals, like alum, say, for example. Okay? Tinatanggal natin yung mga impurities sa alum. So, usually, we allow the alum to recreate its crystal. Tutunayin natin siya tubig para matanggal yung mga impurities na pwedeng matunaw sa tubig or whatever solvent we're going to use. Then we're going to reform the crystal by oversaturating the solution. Okay? So through this class, what happens is nagre-reform ngayon yung crystals kasi super saturated na yung solution natin. Alright? Okay, so yun lang naman siya. So like, it's supposed to be an experiment for physical pharmacy. So siya ito tingnan pag nakita mo biglang bumuo yung yung mga crystals niya. Okay? Sayang, wala naman kayong aparato siguro sa mga bahay niyo, no? Laking Erlenmeyer, hot plates. Yan, sayang. Anyway, malay natin, baka balikan nyo to lahat pag pwede bumalik ng school. Okay, so this is the one class I was telling you about. Ito yung mga definitions natin class for solubility, descriptive term. Okay, these are the quantitative description for solubility. Okay, so normally class is expressed in parts. Alright, so kung halimbawa, ang parts natin is expressed in grams. Okay, so 1 gram, pag if a solute dissolves, 1 gram of solute dissolves in 10 grams of water, then we say, class, that your solute is freely soluble. If it's less than 1 part, about 1 gram in 1 gram of water, 1 gram, parang liit nun, no? About 10 grams na lang, in 10 grams of your solute in 10 grams of water, natutunaw siya, or less than 10 grams, okay, ng solute mo, natutunaw sa 10 grams of water, then class, okay yun. Ibig sabihin, it's very soluble. Okay? So, nagets ba, class? Ito lang naman yung definition na dyan, eh. Kung 10 to 30 parts of your solute, okay, is soluble, then it becomes, tawag na ito, soluble. So, 30 to 100 parts, sparingly soluble. 100 to 1,000 parts, slightly soluble, and so on and so forth. Okay? So, if you're planning, class, to say, for example, create a medication, okay, obviously, class, you have to determine ano yung solubility niya in certain solvents. So, of course, class, ang standard solvent na ginagamit natin would still be water. Right? In 1 part of the solute. So, parts of solvent required to dissolve 1 part of the solute. So, what are the factors affecting solubility? So, these are the most common factors, class. Alam niyo na to. Temperature, definitely. Okay, polarity and hydrogen bonds. Sabi nga natin, polarity, kung yung dapat, define yung positive or negative. Okay, then hydrogen bonds, the presence of functional groups that can create hydrogen bonds. A good example, of course, would be the OH or the hydroxyl functional groups. Okay? Normally, class, pag nakakita ka ng OH sa isang chemical structure, malaki ang possibility, class, na yan ay water-soluble. Okay? Normally, because of the presence of the OH groups. However, class, there are other factors you have to consider para malaman kung magiging soluble ba ang isang compound with a hydroxyl group sa tubig. Okay? Sa mga titingnan natin dyan, class, would be how much carbon chain does it have? Yung aliphatic carbon chain niya. Familiar ba kayo sa term na yon? Aliphatic hydrocarbons. Pag sabing aliphatic, hindi na masyado. Okay, alam niyo yung cyclochain or
Opo, sir.
Pag cyclo, ibig sabihin, nagpo-form ng
Ring
good.
po.
Kumbaga, kung ito yung ito yung mga carbon groups, di ba? Kahit hindi mo na isulat yung C dito, automatic alam natin carbon ito. Okay, so this is carbon. So cyclic yung kanyang structure. Pag aliphatic, class, usually straight chain. Okay, so halimbawa yung ganito, yung gumaganon-ganon, straight chain yan. So kung titignan mo yan, kaya lang naman yun eh, 1, 2, 3, 5, 6, 7, yan. It's a straight chain. Technically, it's a straight chain, straight yan. Okay, so that's an aliphatic hydrocarbon. Isang straight na siyang ganon. Okay, pero pag cyclohydrocarbons, okay, cyclic yung kanyang structure, so obviously, pa-hexane. Or not necessarily hexane. Okay, pa-benzene ring. Okay, pabilog na lang. Huwag benzene ring. Pag benzene ring, ibig sabihin may alternating double bonds yan eh. Okay, something you know already in chemistry, right? Yeah. So anyway, class, I'll talk more about that later. Okay, another factor, class, to consider would be, of course, particle size. Okay, dito papasok yung science of micromiretics. Okay, micromiretics. Some processes that we can use to reduce the particle size. Okay, ano yung science behind it? Right? Is it always good to reduce the particle size of your compounds? So those are things that we will be studying here. Okay, pero for now, class, it's not part of our topic for today. Pero gusto ko malaman ninyo that one of the factors affecting solubility would still be particle size. pH, we have a separate topic for this. That's for next meeting. Next meeting. Okay? We'll be talking about the Henderson-Hasselbalch equation and its application, class, not only in terms of solubility, but how the drug will behave inside the body as well. Okay? Kaya, class, nag-separate tayo ng topic for pH alone. Of course, next would be solvents. What type of solvents are you using? Is it polar, non-polar? Okay, so obviously, anong klaseng solutes ang pwedeng matunaw sa polar at non-polar solvents? Okay, and then lastly, class, pressure. How does pressure affect solubility? Right? Okay, let's talk about temperature. So temperature, class, dalawa lang naman ang dyan, exothermic or endothermic. Pag sinabi natin endothermic, ibig sabihin it's absorbing heat. Okay? The solution or the solution is absorbing heat. Kaya positive ang heat. Papasok sa kanya. Pag negative heat ng solution, ibig sabihin, heat is leaving from the, solution itself. So it's endothermic. Now, how does temperature, class, play a vital role in terms of solubility? Okay? So when there is an increase in temperature, ano sinasabi natin sa solubility of solutes? Tumataas ba o bumababa? Okay? Yes, very good, Mr. Ray.
Po.
Okay, very good, Mr. Otto. Tataas yun. So obviously, class, pag binabaan mo ang temperature, bababa ang solubility ng solutes. With the exception of what type of solutes? What state, or what kind of solute? Okay, ang exception sa rule na to. Ito kasi ang general rule eh. Pag tumataas ang temperature, tumataas ang solubility. Tama? Yan ang general rule for solubility of solutes. Except for what type of solute. May exception lagi tayo sa rule. Okay? Okay, sige, hanyo na. So, okay? So, class, if your solute is a gas, okay, it's a gas, how will you allow the solubility of a gas in a liquid? Do I increase temperature or do I decrease temperature?
Decrease temperature
Very
po.
good. Okay, di ba sabi natin, class, ito yun, nilagyan natin ng star dito, gases are more soluble in cold solvent than in hot solvent. Why? Kasi you're allowing the molecules of your gas to create van der Waals forces para mag-bind sila to allow it to dissolve in your liquid. Right? Siya lang yung exception sa rule na to. Generally, all solid and liquid solutes, class, if you increase temperature, tataas talaga solubility nila. Tama? Tataas ang solubility. Maliban lang, class, kung ang solute na gagamitin mo is a gas. Eh, di ba, how do we liquefy a gas? Normally liquefy a gas through reducing its temperature para maging liquid siya. Right? Kaya nga di ba meron tayong adiabatic expansion, Joule-Thomson effect. Okay, i-compress mo muna yung gas as rapidly allow it to expand for it to lose its kinetic to lose its temperature. Okay, para mag-liquefy siya. At pag naging liquid na siya, class, obviously, mas napapabilis yung kanyang dito, ang kanyang solubility papunta sa liquid mo. Okay? We'll talk more about this later, class. Alright? Solubility of gas in a liquid. Pero one of the applications of this class would be, walaan nyo kung ano. Ano application natin dito? The solubility of gas in a liquid. Araw-araw nitong iniinom, siguro. Ako, araw-araw ko iniinom, masama nga. It's sodas. Soda. Coke. Pepsi. RC. Ano bang iniinom nyo? Sprite?
RC po.
RC, yun. Oh. Ako, araw-araw halos uminom ng RC. Masama yun. Just so you know. Okay, pero ginagawa ko pa rin. Anyway, so class, ano ba ang gas na nakadissolve sa RC natin? Or sa ating cola? It's
Carbonate po.
it's actually carbon dioxide.
Ayan.
Okay? It's carbon dioxide. So class, paano na-ipasok or na-integrate si carbon dioxide sa water? Pinainit ko ba yung cola? Hindi, di ba? Pinalamig ko yun. Kaya class, di ba mas masarap inumin ang Coke pag malamig? Kasi mas nade-dissolve ang carbon dioxide. Kaya pag inom mo, ramdam na ramdam mo yung fizz. Hindi tawag natin. Yung ganyan. Yung pag-burp mo ganyan, class, you're actually releasing the dissolved carbon dioxide in your soda. Try to drink, class, a soda that is stale. Painitin mo yung soda. Okay? Makikita mo, wala ng carbon dioxide na dissolve sa soda na yun. Kasi, ininit mo siya. So therefore, the gas will not dissolve anymore in that liquid. Instead, magle-liberate siya. Okay? Make sense? Does that make sense? Okay. I'll teach you mamaya, class, how to compute the amount of pressure you need to allow your gas to dissolve in a liquid. So paano ba natin pine-pressurize, up to what pressure dapat lagi bago mo isil yung isang soda. Just so you know, sodas, class, were created by it was discovered by a pharmacist. Okay, yung soda. Kasi ginamit niya yon to deliver medications. Nakalimutan ko na kung anong klaseng medication yon. Kasi nga, class, di ba, medications tend to taste bad. Okay, by putting carbonation in your drinks, it actually masks the taste. You learn more about this in manufacturing pharmacy. Paano natin tinatago yung masasamang lasa ng gamot? One technique there would be put your drug in a carbonated drink. Di ba ang sarap-sarap ng Coke, ng soda? Okay, what makes soda taste so good, class, is simply the fizz, yung bubbles. Okay, it makes the soda taste so good, right? Okay. Meron ba itong hindi umiinom ng soda? Kung meron man, ay congratulations. Ang lakas ng willpower nyo to resist. Yeah. Okay, next factor, class, would be polarity and hydrogen bonds. Okay, so the chemical structure of your compounds, of your solute and your solvent, okay, greatly influences, class, its solubility. Okay, through the dipole moment, dielectric property, or hydrogen bonding. So pag sinabi natin, class, dipole moment, okay, ibig sabihin, define yung positive and negative side ng structure natin. Makikita mo, class. Okay, remember our example yesterday, formaldehyde. Okay? So kita-kita doon, class, ang direction ng electrons. Okay, mas papunta lagi sa oxygen side. Unlike that of carbon dioxide, which is a non-polar, equal kasi yung direction ng pag-pull ng ating pag-pull ng ating electrons. So tendency, class, parang may dalawang side ako doon na negative. So if this is carbon dioxide, okay, technically, class, I have two sides here that's negative. Okay, one that is slightly positive. Okay, unlike that of formaldehyde, okay, dito, class, obviously, ang direction ng electrolytes, ng electrons ko, papunta lahat dito. This is definitely, oxygen will definitely be negative. Dahil hinatakan ni oxygen si carbon, okay, obviously, magiging slightly positive si carbon, same goes, of course, with hydrogen. Magiging slightly positive sila. So there's a clear cut kung asan ang negative at positive. Pag ganito yung direction. Okay? For formaldehyde. Pero on the other hand, dito sa carbon dioxide natin, kitang-kita, class, both sides may negative. Okay, so hindi ganun ka-defined ang polarity niya. Kaya masabi natin, carbon dioxide is a non-polar substance. Okay? So tawag natin doon, class, the dipole moment. Define ang direction ng, define yung positive at saka negative sides. Right? So a dipole molecule has a concentration of positive charge at one end and a negative charge at the opposite end. So here's the positive charge. Andito yung negative charge. On the case class of carbon dioxide, okay, one side is negative and the other side is still negative. Okay? So wala siyang dipole moment na tinatawag natin. Okay? Hindi siya nakakapag-moment. So molecules class with high dipole moments are more soluble in, obviously, polar solvents. Kasi polar solvents class have both positive and negative side. Okay? So does that make sense, class? Does that make sense? Okay. So then meron siyang defined positive and negative side. Now, class, the only way kaya na-dissolve natin si carbon dioxide sa water is through other means. We manipulate other factors. Okay? Hindi lang naman kasi hydrogen bonding or polarity yung main reason how we can allow a solute to dissolve in liquid, say, for example. For carbon dioxide class, kaya natin siya napapatunaw sa tubig is simply by manipulating pressure and temperature. Okay? Nagets ba? Alright, so hindi lang naman kasi class ito, marami, nakita nyo naman, di ba? Ang daming factors affecting solubility. So polarity is just one. Pero we can always, kumbaga, pwede natin gawa ng loophole yun. Dahil hindi siya polar, hindi siya matutunaw, hindi pwede pa natin gawa ng paraan yan. So manipulate other factors like pressure and temperature. Okay, so next one is dielectric constant, so relates to the ability to store charge. Okay, so water has a high dielectric constant than alcohol, whose electronegative oxygen pulls electrons from the hydrogen, thus creating partial charges. So may partial positive, partial negative side ka. And then lastly, class, is the presence of hydrogen bonds. Presence of functional groups, class, like hydroxyl groups, amine groups, okay, or sulfhydryl groups. Okay? Lahat ng ito, class, the presence of these functional groups can cause your molecule to create hydrogen bonds. And therefore, dahil meron siyang capacity to create hydrogen bonds, malaki ang possibility na magiging soluble siya sa water. Okay? Hindi lang naman water, class, any polar solvent for that effect. Okay? Pero sabi natin general ang usual naman na solvent na gamit natin is water. So please take note, I'll be mentioning water most often. Okay? Pwede naman alcohol, acetone, it's still polar. Okay? Pero again, water pa rin ang usual na ginagamit nating solvent. So class, again, the presence of these functional groups can give you a sign na soluble siya sa tubig. Okay? Or any polar solvent. So are we clear? Good. Okay. So just so you know, class, sa mga succeeding quiz natin, ganun lang ang tatanungin ko. I'll just show you structures. Tatanungin lang kita, is it soluble or not? Okay? Yun lang naman mga tatanong ko dyan. Tapos bibigyan ko kayo ng, say for example, 10 parts ang kailangan kong solvent to dissolve 1 part of the solute. Is it freely soluble? Freely soluble? Very soluble? Slightly soluble? Mga ganun-ganun lang mga tanong ko dito. Okay? Okay. Para hindi nasa search agad-agad lang sa ang mabilisan sa internet. Okay? At napapractice yung critical thinking skills natin. Next one, class, particle size. So micronized drugs may have increased solubility over a drug that is not micronized. So micronization, class, meaning ni-reduce mo particle size. So it increases the solubility of if the process breaks down the crystal lattice of a solid. Okay, the breaking of the bonds kasi, class, of the crystals by micronization will reduce the energy required to separate the solute from itself. Halimbawa, class, ano mas mabilis tunawin? Isang bloke ng asin or yung durug-durug na asin?
Durug-durug na asin.
Very good, Miss Cabalan. Very good, Miss Pihoto. So, obviously, class, pag durug-durug na yung asin, mas mabilis siyang tunawin, right? Kasi nga, na-break mo na nagkaroon ka ng initial physical breakage of their bonds. Okay? So, by adding water into it, you allow the water to use less energy to break the bonds further. Right? So, I hope that makes sense. Okay? So, here are some general rules, class, in terms of solubility. This is just a general rule. It's not absolute. Okay? Pero ito yung common sa halos lahat. Like dissolves like. I think obvious na to, right? Polar solutes dissolves in polar solvents. Water-soluble solutes dissolves in water. Non-polar solutes dissolves in non-polar solvents. And vice versa. So lipid dissolves in lipid solutes. Lipid solutes dissolves in lipid solvents. Sorry. Okay? So tama? Are we clear? So sabi natin, ang principle then is like dissolves like. Okay, again, class, the presence of the following functional groups. Not only this, okay, pero ito yung mga usual. Okay, hydroxyl, amine, carboxylic acid. Okay, all of these functional groups, class, can create or allow your molecule to create hydrogen bonds with water. Therefore, allowing them to dissolve in water or any polar solvent. Okay? Now, normally class, the greater the number of carbon atoms in the solute, the less is its solubility in water. Kaya tingnan nyo class, ang mga oils, natutunaw ba sa tubig? Hindi siya matutunaw, right? Not unless you put a surface active agent. Mag-introduce ka ng another compound to allow its solubility in water. Pero generally class, no, because most oils class, okay, mahaba yung aliphatic hydrocarbon chain niyan. Okay, mahaba yung carbon chain niya. Tingnan nyo, linoleic acid or canola, halimbawa, canola oil na lang. Okay, 24, I forgot kung ilang carbon chains yun, pero mahaba yung carbon chains niya. Okay, so therefore, class, the longer the carbon chain is, the lesser will be its water solubility. So halimbawa, magtatanong ako sa quiz or sa exam, papakita ko dalawang structure ng ng oil. Okay, so halimbawa, tatlo ang carbon, yung isa, 10 ang carbon. Tanong ko lang dyan, which one will be soluble in water? A or B? Okay, so obviously, it's kung yung A yung mas maiksi, yung tatlong carbon, si A yun. Mas magiging more soluble in water. Alright? Okay, tapos halimbawa, dagdagan ko pa yung tatlong carbon yun, may hydroxyl group pa, making it an alcohol. Okay? So talagang mas magiging water soluble nga yun. May hydroxyl group na eh. Alright? So yun. Next one, higher melting points. Solutes with higher melting points tend to have lower water solubility. Kaya nga class yung mga ionic, okay, mga ionic compounds, okay, which have higher melting points, tendency class, in terms of water solubility nila, mahihirapan sila. Okay? Although, ions class can dissolve in water, pero because of their, lalo na pag talagang slab, isang crystalline slab yan, okay, which is, like rock salt. Okay, matatagalan bago matunaw yun sa tubig. Okay, it can dissolve in water. Please take note, it can dissolve in water, but it's going to take time. Hence, reducing its solubility in water. Next one, cis isomers are more soluble than trans isomers. I think familiar naman sa inyo to, right? Confirmation. Okay, cis isomers, that's a one side lang. Mga functional groups. Pag trans, on the opposite side. Okay, mga functional groups niya. Like say, for example, ito yung structure mo. Okay? So, excuse me. So, halimbawa, hydroxyl groups ko nandito. Okay, CH3 na to. H3. Tapos, ang isa kong, isa kong compound, CH3. Ito naman siya, OH. So, dito isa, OH. Okay, so sino ang cis? Sorry, A or B? Sino si cis? This is isomer. Very good, it's A. Okay, siya yung cis. Kasi class, nasa one plane lang yung kanyang mga functional groups. Ito isang side lang. So, kaya nga dito makikita kung levorotatory or dextrorotatory yung mga functional groups ko. Or yung aking compound. Okay, so this one is cis. This is a cis isomer. This one is a trans isomer. Okay, yung functional group niya is on opposite sides. Alright, so between the two class, again, normally mas soluble si cis kumpara kay trans. Okay, that's a phenomenon that usually happens class to most of our solutes that are of different isomers. Okay? Alam niyo siguro isomers, right? Same chemical formula, different lang orientation ng kanilang functional groups. Okay? Same chemical formula. Okay. Next one, class. Alright, so halimbawa, again, papakita ko ng comparison ng isang isomer, isang cis, isang trans. Tatanungin ko lang, sino dito mas soluble sa tubig? Si cis o si itong compound na to o si compound na ito? Kaya usually don't put names para hindi nyo ma-search lang agad-agad sa internet. Okay? Mahirap mag-search pag structure, ha? Anyway, so yun. And then class, lastly would be anhydrous solutes are more soluble than the crystalline ones or the hydrous ones. Okay, anhydrous class, ibig sabihin, anong meron dito? Anhydrous solutes are, pag sabing
hydrophilic, sir.
Sorry, it's hydrophilic, yes, correct din naman yon. Okay, pero may property class ang isang tinatawag na anhydrous solute. Ang counterpart na class is a hydrous solute.
Wala siyang sir?
Water. Yes, sino yan? Miss Kim? Abines?
Yes, sir.
Ano yan?
Po? Anhydrous po parang compound siya containing na walang water. Ganun
Yes,
po.
very good. So class, ang hydrous solute may water molecule. Ibig sabihin, yung kanyang molecule itself contains water. Halimbawa, nakalimutan ko na kasi yung formula, citric acid. Sulat ko lang citric acid, dapat pasensya nyo na. Hindi ko na maalala ang formula nito. Okay, kung ano man yung chemical formula nito, tapos makikita ka may dot H2O. Minsan makikita may dot 2H2O yan. So it contains 2 molecules of water. So the entire molecule contains water. That indicates it's a hydrous molecule. Now, class, pag usually nakita mong citric acid lang. Okay? Citric acid lang yung formula. Ganyan lang. Wala siyang .H2O. Ibig sabihin, anhydrous yun. Ibig sabihin, walang water molecule. So, are we clear? So, class, halimbawa, kung titingnan mo, bibili ka kunwari ng USP grade reagents. Tapos nakita mo, class, sa reagent na yun, may .H2O ang chemical structure. Ibig sabihin, yung chemical na binili mo actually contains water molecules. Make sense? Okay. So, class, between the crystalline ones or the hydrous ones versus the anhydrous ones, mas mabilis matunaw sa tubig si anhydrous. Okay? Mas mabilis siya matunaw. One main reason dyan, class, isipin nyo parang ganito na lang yan. Pag anhydrous kasi, class, di ba wala siyang tubig. So therefore, pag nakakita ng tubig yan, sobrang excited yan. Okay, magiging sobrang excited yan. Nagets ba, class? Halimbawa, pag huwag na nga lang, kalokohan lang naisip ko. Basta yun na lang. Okay? Anhydrous, ibig sabihin, wala siyang water, mas nasasabik. Nasasabik siya makakita ng tubig. Kasi anhydrous siya. Ngayon pala siya kumbaga makakita ng tubig. Alright? So, yun. Okay. Next factor, class. Next factor affecting solubility. So, we have a separate topic for this. Pero just so you know, pH plays a vital role in solubility. So, a weak acid such as phenobarbital is oftentimes is soluble in values with high pH, normally in the alkaline range. And the ionic form is converted into its molecular phenobarbital as the pH is lowered and below 9.3 ang pH niya. It starts to precipitate. Okay, so a base naman would usually precipitate at if the pH is elevated. So what am I saying here, class? Okay, kapag weak acid kasi ang gamot mo, tapos ang iyong solvent is a base, acid and a base, di ba? Okay, acid, sabi natin, can donate protons, bases usually accept electrons. Okay, so positive, negative, may affinity sila towards each other. That's why, class, oftentimes, if you have a weak acid, mas mabilis siyang i-dissolve in a base solvent. Okay? And vice versa. So, kung weak base naman ang iyong, ang solute mo is a weak base, obviously, mas magandang solvent dyan would be an acid solvent. Okay? Para mas matunaw siya. Kaya tingnan nyo, class, kung weak base ang gamot mo, if your solute is a weak base, tapos nilagay mo siya sa solvent na base din, ano nangyayari? Starts to precipitate kasi hindi siya natutunaw. So, make sense? Okay, so I hope that makes sense. Pero class, we'll have a more in-depth discussion about this next meeting. Okay, when we start talking about electrolytes, how pH affects solubility. Next one, effects of co-solvents. Now, class, madali lang intindihin to eh. Ano ibig sabihin pag sinabi ng co-solvent? Co-solvent. Ano, collaborate.
Same po na solvent, pinagsama
Very
po.
good. Ibig sabihin, class, imbis na isang solvent na ang ginamit ko, gumamit ako ng dalawang solvent. Okay? So, class, co-solvency is simply the phenomenon when a solute is actually more soluble in a mixture of solvent than just in one solvent. A good example of this, class, is phenobarbital. Phenobarbital, class, doesn't necessarily dissolve immediately in water, not unless you adjust the pH. Okay? Just so you know, weak acid kasi si phenobarbital. Pero if I make my solvent class basic, natutunaw yan. Okay? I can increase its solubility by making my water basic. Right? Just so you know. But, what if neutral ang aking water? I'm going to use a neutral water. A buffered water, say for example. So class, si phenobarbital, hindi agad-agad din matutunaw sa tubig. Not unless you add alcohol and glycerin to the mix. Usually 1:1:1 yung mixture natin. Okay, so adding those three solvents, class, makes the solubility of phenobarbital much better. Just so you know, class, water, alcohol, glycerin, they are soluble with each other. Okay? They can dissolve with each other. May maraming hydroxyl bonds, class, hydroxyl functional groups ang glycerin and alcohol, which allows it to dissolve in water. Are we good? Kaya makaka-produce ka pa rin ng homogeneous mixture with the combination of water, alcohol, and glycerin. Okay, so the three solvents, I'm using three solvents here just so that phenobarbital can dissolve. So ang process na in class known as co-solvency, or that phenomenon is known as co-solvency. Okay, kaya minsan class makikita niyo sa mga researches, imbis na water lang ang ginamit nilang solvent to extract their constituents, kaya ba yung dahon-dahon? Di ba ganyan yung mga usual, mga sikat na research sa atin, dahon-dahon. tapos pinapakuluan or ini-extract yung components ng dahon-dahon. Depende kasi sa target na solute na gusto mong kunin sa dahon. Minsan, class, nagko-combine tayo ng mga solvents. We combine solvents. Ang pinaka-common na combination would be water and acetone or water-alcohol mixture. Okay? Mga ganun. Right? Water acetone or water-alcohol mixtures. So, yun na naman, class, gusto kong malaman dito about co-solvency. So, you can add different solvents. Okay, so the solvent affects the solubility of a weak electrolyte in a buffered solution in two ways. Okay, so the addition of an alcohol to a buffered aqueous solution of a weak electrolyte increases its solubility of the unionized species by adjusting the polarity of the solvent to a more favorable value. I'll talk in more details about this next meeting. Next meeting. Okay, wag mo natin masyadong pag-isipan to, pero gusto ko lang malaman yung class na if you want to increase the solubility of an acid, then make your solvent basic. Or vice versa. A weak base solute, you want to dissolve it, make sure, class, that your solvent is a weak acid, is an acid or acidic kahit paano. Okay, kung hindi, mag-co-solvent ka, pwede rin naman. Kung hindi pa rin yun, adjust temperature. Pero again, class, if you adjust temperature, ang mangyayari, pwede rin masira yung solute ko because of the increase in temperature. Alright, so ang dami factors na kailangan consider. Okay, pero just so you know, those are some things that we can do. Now, what affects the poor aqueous solubility of certain solutes? There are two main factors, class, that can affect its aqueous solubility. One would be lipophilicity. Lipophilicity, class, ibig sabihin yung kanyang nature is basically lipophilic. Saan siya natutunaw? Sa non-polar solvents. Hindi niya kayang matunaw sa polar solvents for one main reason, pwedeng mahaba yung kanyang aliphatic hydrocarbon chain. Okay, masyado siyang maraming carbon chains. Again, increasing the number of carbons, class, in a chain can actually reduce its solubility in water. Okay? So, the therapeutic dose and potency, the next second pala is strong intermolecular interactions. So, ibig sabihin, class, the stronger the molecular interaction between two compounds, okay, the harder it is to dissolve in water. A good example na lang, class, bakal. Okay, iron. Kaya bang matunaw agad-agad ng bakal sa tubig? Ang tagal niyan. Di ba, mag-rust mo na yan, magiging ferrous oxide mo na yan, hanggang bago siya matunaw. Pwedeng matunaw ang bakal sa tubig, just so you know. But it takes time. Okay, it takes a lot of time. So, are we clear? Because of the strong intermolecular forces of interaction between the iron molecules. Okay? Does that make sense? Yeah. So, therapeutic dose and potency, class, of drug depends on the solubility of the drug because only the dissolved form of the drug is capable of being absorbed, obviously. Kaya nga, class, actually, you'll learn more about this in pharmacokinetics. Pero basically, class, ano ba dapat ang property ng gamot ko para ma-absorb siya into my body? Should it be lipid-soluble or water-soluble? Generally speaking, dapat ano ang property ng gamot ko? Is it lipid-soluble or water-soluble para makapasok sa loob ng katawan ko?
Lipid-soluble po.
Both? Okay. Pwede rin, Ms. Mihoto, lipid-soluble, water-soluble, Ms. Heidelin? Okay. Now, class, think of it this way, Dapat both, yes. Actually, dapat both. Pero, class, majority of your drug should be water-soluble. Majority. I'm not saying all, Kasi, class, kung majority naman ng gamot mo is purely water-soluble, papasok yun sa katawan ko, lalabas lang agad-agad sa ihi ko. Okay? It's not going to stay naman inside my body. Kung highly lipid-soluble naman ang gamot ko, hindi naman siya papasok sa bloodstream ko. Kasi, again, class, blood is mainly composed of... Saan ba gawa ang dugo natin?
Water po.
Yes, it's mainly composed of water. Very good, Miss Canopio. Okay, Miss Mihoto? So, it's mainly composed of water. So, sabi natin, di ba, like dissolves like. Ano lang ang mga gamot na pwedeng matunaw sa dugo natin? Di mga water-soluble, lipid-soluble drugs.
Water-soluble po.
Good. Definitely, class, it's going to be only water-soluble drugs. Pero, class, sabi ko nga, kinagandahan, class, ng ating mga gamot, majority, actually, almost all of the drugs in the market, class, are weak electrolytes. Pag sinabi natin weak electrolytes, it's partially lipid-soluble and partially water-soluble. Both at the same time. Are we clear? We'll talk more about that, class, sa pH na, sa electrolytes natin. Pero basically, class, if you want your drug to be absorbed into your bloodstream, it must be water-soluble. Kaya nga class, wala kang gamot na makikita sa market na hindi natutunaw sa tubig. At not unless you're dealing with ADEK, vitamins A, D, E, K. Kasi ang process naman ng absorption nila would be via phagocytosis. So hindi nila kailangan maging water soluble. Okay? The lipid-soluble vitamins. Okay? Pero majority of our drugs class definitely should be water-soluble. Okay? So we'll talk more about that when we start reaching electrolytes. Okay? But again, for a drug to create potency, to create an effect, it must first be soluble in the body. And of course, the body is 60% water, so therefore, my drug should be at least soluble in water. Next factor class affecting solubility would be pressure. So the effects of pressure changes on the solubility of solid and liquids are negligible. Okay, ang pinaka naapektuhan class ng pressure would be the solubility of your gases. Okay, remember class, sabi natin, di ba sa ating mga gas laws, okay, an increase in pressure would actually increase, okay, solubility, of gas in liquids. Okay, an increase in pressure. So obviously, class, the effects of pressure on the solubility of gases in liquids can be best described with the use of Henry's law or the Le Chatelet principle. Okay, pero for the class, we'll be talking about the Henry's law muna. Okay, so ano ba yung meron sa Henry's law na to? Hindi natin binanggit last time, di ba? Okay, because this time class, it's a separate topic kasi for solubility per se. Okay, to be more specific for solubility. So an increase in pressure, sabi natin increases the solubility of gas in a liquid. Okay? Ay, doon ko pala nilagay yun sa sorry. May separate slide nga pala ako for this one. Pero class, we'll talk more about Henry's law in a while. Okay, once we start to discuss the solubility of gases in liquids. Para makita nyo rin class, paano ko nalalaman kung gaano kataas na pressure ang kailangan kong ilagay sa bote ng isang Coke. Okay, para matunaw yung carbon dioxide ko. At the same time, okay, dahil pinapalamig ko yun, so ang nangyayari, yung carbon dioxide ko, mas natutunaw pa lalo sa liquid. Hindi kaya pag binuksan mo yan, di ba gumagano yan? May popping sound. It's because class, the pressure inside the glass or the bottle, okay, is very high. Tapos nirelease mo yun. So, gagano yan. Right? Have you noticed, class, that the colder your beverage is, lesser ang sound niya ng yung sound na yun? Ano matawag sa sound na yun? Yung fizz sound? Palamigin mo kasang bongga ang Coke mo. Pansinin mo, pag binuksan mo yan, parang gumagano lang yan. Yan lang yan. Pero pag medyo hindi ganun kalamig, ang lakas. Ganun agad yun. Have you noticed? Na-notice niyo ba yun? O ako lang nakakapansin nung dati. Actually, hanggang ngayon, pinapansin ko pa rin pag bibili ako ng Coke or RC. Okay? Notice class kasi the colder it is class, ang tendency, yung gases nasaan? Mas nagdi-dissolve siya sa liquid. Okay? Ibig sabihin, pag binuksan mo siya, pag sobrang lamig ng drinks mo, pag bukas mo ganyan, majority of the gases are inside the liquid na. Nag-dissolve siya doon. Kaya konti lang yung ganun niya. Okay?
Pero
paano
naman po sir kapag sabi nila kapag masyado daw na naalog yung lalagyan pa ng bote.
Inalog mo siya, class. Pag inalog mo siya, syempre na-disturb, in-increase mo yung kinetic force within the gas molecules, right? Na-excite mo siya because of the vibration you introduce. So, nangyayari ngayon, class? Okay, dahil na-excite yung molecules niya because of the shaking. Okay, tayo si class, na-release siya from the liquid. So, ngayon, nag-build up yung pressure within, pero dahil walang takas di ba? Airtight yon, hindi nakakatakas yung molecules. So, once you open it up, mag-rush out yung mag-rush out yung air, yung gas na dinisolve mo doon sa liquid. May technique daw dyan para hindi pumutok nakalimutan ko na May babalik rin mo tapos kakatukin mo yung ilalim. I don't know. I forgot. May explanation yan. Okay, there's a scientific explanation on how you, parang juice na lang po pag hindi na malamig. Pwede rin, actually. Okay? Pag hindi malamig ang juice, di ba, hindi na rin masarap. Okay. So anyway, so yun. An increase in pressure increases solubility of gas. Now, let's talk about class solvent-solute interactions. Okay, so this time class we'll talk about polar solvents, non-polar solvents, and semi-polar solvents. Okay, so for polar solvents class, sabi nga natin, an important factor class for us to determine whether a solvent is polar or not would be the presence of a dipole moment. A dipole moment class is simply the presence of a defined negative and positive side in your molecule. Okay, defined yon. So kung ba class, ito nga, like this one. you'll know this molecule is polar because one side is positive and the other side is negative. Okay? So defined yung kanyang polarity. Now, class, alam kong halimbawa, two identical non-metal like my halogens is a non-polar molecule because nag-sharing sila ng electrons nila equally. There's equal sharing. Okay? Normally, class, makakakita ka ng, tawag dito, makakakita ka ng defined positive and negative charge kung ang iyong molecule class contains a more electronegative molecule. Kumbaga malaki ang difference ng electronegativity between the molecule. Let's say for example, okay? Ang pinaka-paborito ko example, water. Okay? Kitang-kita nyo class ang difference sa electronegativity, right? Ang laki ng difference. Very electronegative si oxygen, so therefore, automatic ito yung mas magiging negative. Ang layo ni hydrogen sa spectrum ng electronegativity, nasa other side siya. So therefore, class, hydrogen becomes very positive. Unlike that class with a combination of carbon dioxide. Sorry, paulit-ulit na lang yung example ko. Ito kasi pinaka-simpleng explanation eh. Ito yung pinaka-simpleng example ko. Class, hindi ganun kalaki ang difference ng electronegativity between carbon and oxygen, right? Halos magkatabi lang sila. Number 4 si carbon, number 6 si oxygen, right? Okay, so isang molecule lang naman ang pagitan nila eh. Isang element lang naman. So class, in terms of electronegativity, it's not that different. Kaya class, less ang kanilang dipole moment na tinatawag natin. Right? So are we good? So class, if you look at the compound, nakita nyo na yung mga elements within the molecule, yung chemical structure niya, halos pareho lang ang kanilang mga electronegativity or hindi ganun kalayo ang difference. Malaki ang probability class magiging non-polar yan. Like halimbawa, oils contains carbon and oxygen all throughout its structure. Okay? So malaking possibility na magiging non-polar yun. Right? Pero kung makikita mo kasi oxygen and hydrogen lang, ang laki ng difference ng electronegativity nila, malaki rin makikita mo malaki rin ang possibility na magkakaroon siya ng charges talaga. Okay, make sense? Does that make sense? Okay. So therefore, class, yun na nga. It makes the solvent polar. So therefore, if the solvent is polar, polar solutes can easily dissolve in it. Okay, so polar solvents class have large dipole moments and tend to be dissolved in water, while those with near zero dipole moment, okay, are mostly considered to be non-polar, and it's insoluble in water. Okay, pure iodine class, hindi yan natutunaw sa water, not unless you add what? Ay, nagawa niyo na ba experiment na to? Or na-discuss sa inyo? Pure iodine class is in crystalline form. Okay? Di ba sabi natin, ito yung isa sa mga examples ng compound na nagsasublimate. Okay? Sublimate, ibig sabihin, hindi siya dumadaan sa liquid state. Diretso agad siya sa gaseous state. The only way class you can dissolve iodine is to add potassium iodide into your solution. Potassium iodide is a salt. Okay, which allows the salt, yun ang ina-add natin class sa water, to increase the solubility of iodine in water. That's Ki. So, potassium iodide. Kaya nga meron tayong Lugol solution. Alam niyo yung Lugol solution? Betadine na lang. Alam niyo betadine? Okay, di ba that contains iodine? Just so you know, class, povidone iodine doesn't only contain povidone, also contains potassium iodide. Kasi hindi matutunaw si iodine class sa tubig. You don't really get iodine in its solution form. In its pure form, okay, wala ka makukuha ang iodine in its pure form na liquid. Sabi nga natin, class, siya yung isa sa example ng mga elements na pag pinainitan mo, diretso gas yun. Okay, nagsa-sublimate yun. Alright? So, hindi siya dadaan sa liquid state. So, if you want to make an iodine liquid, you have to dissolve it in water. And for it to dissolve in water, you need to add naman potassium iodide. Kasi just so you know, class, non-polar si iodine. Iodine itself, I2 is non-polar. So, obviously, hindi siya talaga matutunaw sa tubig. Not unless, yun nga, nag-add ako ng another agent to allow its solubility. Technically, parang nag-add ako ng, I won't say co-solvent, hindi naman solvent si potassium iodide. Okay? Basta another agent to allow its solubility. Okay. Next one, for polar solvents class, they have the capacity to create hydrogen bonds. I think I've mentioned this already. Okay, water dissolves phenols, alcohols, aldehydes, ketones, excuse me, amides, and other oxygen and nitrogen-containing compounds that can form hydrogen bonds within the water. Again, class, aabangan mo lang lagi dyan, class, the presence of hydrogen. Okay? And the functional group that it has. If it contains kasi, class, functional groups, like yun na nga, OH groups, okay, COOH, carboxyl groups, okay, and so on and so forth, class, then that indicates that those molecules, okay, can create hydrogen bonds and therefore be able to dissolve in water. Kaya kaya nila mag-create ng hydrogen bonds. Phenol, alam niyo naman ata phenol, right? Okay, it's a benzene ring with an OH on top. Okay, amines, anything that contains NH2. All right, very good. Oxygen and nitrogen containing compounds, hydroxyl groups, obviously OH. Okay, di ba alcohols contains OH? Di ba ang general formula is ROH? ROH, ibig sabihin, whatever aliphatic hydrocarbon na i-link mo dito, basta dagdagan ng OH, magiging alcohol yun. Okay, isang functional group lang, class, OH, pwede na yun. It's already an alcohol. Okay, ROH, ganun. Tapos meron tayo RCOH. Familiar? COH. Okay, or RCOOH. OH na nga lang, mas madali yun. Okay, carboxyl groups. May carboxylic acid ka dito. Right, that's more on chemistry na class. Okay, alam ko sawang-sawa na kayo sa chemistry. Nag-chemistry kayo, di ba? Tama nga ba, nung first year? Ayan. Sa mga namings natin, mga ganyan. Anyway, class, mas malaki ang application to once you start organic medicinals. Dito naman kayo makikita paano nag-bind ang receptor sa gamot natin. Okay, tapos paano malaman kung irreversible ba ang binding, reversible, stuff like that. Tapos makikita mo bakit capable ang isang antibiotic to repel certain enzymes, okay, because of its electronegative nature. Okay, basta nakakatuwang pag-aralan yung mga ganun class. It gives you a better understanding of how our drugs work on a molecular level. Anyway, next one class that affects the polarity of our solvents would be, of course, the structural features of your solute or solvent din naman. Now, as the ratio of polar to non-polar groups, the structural feature that we're talking about here is the ratio between the polar and non-polar groups within the molecule. Now, class, the more ang non-polar group sa molecule mo, obviously, ano nangyayari sa property ng molecule mo? Mas nagiging polar, mas nagiging non-polar? Well, obviously. Okay, dahil non-polar, so mas nagiging non-polar din ng solute mo or ang solvent mo. Okay? Kaya nga, class, ang sabi natin dito is, methanol, soluble sa water, hindi. Actually, pinakita ko na nga dito.
Soluble po.
Okay, so based on this diagram here, class, ito yung solubility niya in water. Methanol, class, only has one carbon chain. Silang carbon yan. Tapos may OH siya. Sabi natin, anything that contains OH, malaki ang possibility muna, malaki ang possibility, class, na mas natutunaw siya sa tubig. Correct? Okay. Excuse me. So, mas lumalaki ang possibility na matunaw siya sa tubig. Now, class, dahil may OH siya tayo dito, tapos isa lang ang carbon chain ko, okay, ito yung polar, si OH. CH3 ito, class, is non-polar. Okay? Non-polar. Technically, almost equal pa sila, right? Almost equal pa. So, therefore, class, mas water-soluble pa rin siya. Technically, it still becomes water-soluble. Now, as I increase the number of carbon chains attached to my molecule, to my aliphatic hydrocarbon, anong nangyayari sa kanyang polarity? Mas nagiging polar, mas nagiging non-polar. Pag dinadamihan ko yung carbon,
Mas nagiging
non-polar po.
mas nagiging non-polar. Kaya tingnan nyo, class, pagdating sa hexanol, okay, soluble pa ba siya sa tubig? Halos hindi na. Okay, halos hindi na. Still soluble, kasi may OH group pa rin naman siya eh. Okay, pero in terms of its solubility, class, nababawasan significantly. So as you increase, class, the number of hydrogen, the number of carbon the number of carbon attached to your aliphatic carbon chain, nawawala, class, ang kanyang water solubility. Are we clear? Just so you know din, class, just so you know, in terms of the antibacterial property of your alcohol, okay, normally, class, the longer the carbon chain, class, nawawala yung kanyang antibacterial property. Okay, so the branching, kapag nagba-branching pala yung kanyang chain. Okay, nagba-branching yung kanyang chain. Na, class, familiar ba kayo sa ethanol? Okay, ito pala, ethanol. CH3, CH2OH. Yan. Okay? So, class, familiar kayo sa isopropyl alcohol? Isopropyl. Di ba sa isopropyl class, yung isang methyl group ko, nag-branch out sa second carbon. Okay, kaya siya tinawag na isop. Isop yung kanyang positioning. So kaya siya isopropyl, nag-branch out siya. So kasi si ethanol, CH3, CH2, OH. Ganyan siya. Okay? So class, tawag dito, ang isopropyl alcohol natin class, okay, ang nangyari dyan class, nag-branch out siya. Okay? Nag-branch out yung kanyang carbon molecule. Okay? So tendency class is, parang ito itsura niya. CH3, C, tapos OH. Okay? So dito si H. So instead class na linear siya, instead na linear yung structure niya, nag-branch out siya. Now once na kasi nag-branch out ang ating carbon groups, once na nagba-branching na siya, ang tendency class is nawawalan siya ng, tawag natin dito, ng kanyang antibacterial property. So sir, so kung yan ang sinasabi niyo sir, ang antibacterial property ng isopropyl ko is poorer than my ethanol? Technically, yes. Pero kasi ang question dyan is, sino mas madaling i-produce? Sino mas madaling i-manufacture? Si ethanol ba o si isopropyl? Between the two class, mas mabilis i-manufacture si isopropyl. Kaya siya yung madalas na makita natin sa mga rubbing alcohols. Nga ba? Kamaya ko ano, tama ako, si isopropyl. We use isopropyl alcohol for rubbing alcohols. Hindi naman kasi ganun ka-significant ang difference ng antibacterial property niya sa ethanol. Although ethanol is better, true. Okay, pero manufacturing-wise, mas cost-effective si isopropyl. Okay? So, FYI na lang yun. Naku, ang dami ko ng FYI. Mauubusan naman tayo ng oras nito. Okay, what about non-polar solvents? Okay, basically, class, it's common for hydrocarbons. If your drug class, or sorry, not drug, your solvent is a hydrocarbon. Alam niyo naman ang hydrocarbons, right? Hydrocarbons are anything that contains carbon, hydrogen, and oxygen. Okay, at defined amounts. So class, if your solvent is a hydrocarbon, automatic non-polar yan. Okay? Automatic, like ethane, benzene, so on and so forth. So class, these hydrocarbons cannot ionize weak electrolytes. Kasi kung titignan nyo naman talaga dito class, okay, hindi ko ma-define definitely kung asan ang negative side, asan ang positive side. Kasi halimbawa, ito ethane na lang. Tingnan nyo to ha. Ethane class, although technically I can say that my carbon here is negative, slightly negative, pero class dito, carbon ko rin to would be slightly negative. Okay? Tapos paikot pa yung structure. Right? So ang tendency class is parang ang pool niya pag ganito. Pag papunta lahat sa carbon, yung electrons, yung pool ng electrons. So are we clear? Kaya class, automatic, alam ko na agad, pag tinitingnan ko to, most likely this is a non-polar molecule. Okay? So it cannot ionize weak electrolytes, so therefore, any solute that has a charge, hindi niya matutunaw. So cannot form hydrogen bonds with non-electrolytes. So they are unable to reduce the attraction between the ions of strong and weak electrolytes because of the solvent's low dielectric constants. Okay, hindi ganun ka-defined yung dielectric constant niya. So therefore, class, hindi niya ma-pull apart yung structure ng solute natin. Ano ba? Sodium chlorine, sodium chloride. Okay? Dahil class, poor ang dielectric constant nito, hindi defined asan ang negative side, asan ang positive side. Although again, pwede naman mag-bond ito sa mga slightly positive kung kailangan. Okay, pero class, hindi niya kayang i-separate si sodium chloride. Ibig sabihin, yung pagka-negative ng carbon molecule na to, hindi kayang hatakin si chlorine. Kasi definitely, mas malakas ang negative property ni chlorine kesa kay carbon dito. Nagets ba? Kumbaga class, may halimbawa, kunwari lang naman, boyfriend, girlfriend, sodium yung lalaki, si chlorine yung babae. Okay? Si chlorine maganda. Tapos may nanlalandi sa kay sodium, si carbon, nilalandi niya. Pero hindi siya ganun kagandahan. Okay, hindi siya ganun kagandahan. So slightly maganda lang siya. Okay, so slightly negative siya. Mas electronegative or mas maganda si chlorine. So saan sasama si chlorine? Si sodium, sorry. Obviously, sasama pa rin siya kay chlorine. Kasi nga, poor ang dielectric constant ni carbon. Okay? Poor. Kasi slightly lang siya, slightly. Unlike that of water class. Water. Okay? We're in class, makikita mo talaga, although this is still technically slightly positive, pero malaki ang difference ng pagka-negative ni oxygen here sa carbon here, right? Okay, enough class to pull away sodium. So kumbaga si oxygen, hindi lang maganda, mayaman pa. Sexy. kay matalino, sabihin natin ganun. Lahat ng hahanapin ni sodium na doon na kay oxygen. So kaya nila makipaghiwalay. Okay? Nagets ba, class? Okay. I hope that makes sense. I hope that makes sense. Alright? Ayun. Kaya, class, again, ions, polar solutes cannot dissolve in non-polar solvents simply because the non-polar solvents do not have the capacity to pull the electrolytes or the attraction between the two molecules apart. Okay? Okay, semipolar. Ano yung mga to? Examples of which would be ketones and alcohols. Alcohols, class, is a semipolar solvent. Kaya nga, kung hindi mo alam kung ano yung substance na gusto mong i-isolate sa isang dahon, normal na ginagamit natin class solvent would be alcohol so that it can extract both polar and non-polar constituents within your leaves. Okay, so it can induce a certain degree of polarity in non-polar solvent molecules. For example, acetone can increase the solubility of ether in water, or alcohol can increase the solubility of water-oil mixtures. Okay? So, kumbaga kasi alcohol kasi it lies somewhere in between. Okay? It's a semi-polar. Right? Semi lang siya. Very good. So, what are some predictors of solubility? So, normally, class, ang titingnan mo lang naman dyan would be polarity or the dielectric constant. Tingnan mo yung dipole moment niya. Okay? Association. Does it dissociate? Okay, in terms of association, class, does it contain a metal and a non-metal? Kung ang compound mo contains a metal and a non-metal, malaki ang probability that's an ion. Okay, it has formal charges, so obviously it's going to dissolve. It's going to be a polar molecule, sorry. And it's going to dissolve in water. Solvation. Okay, solvation is the phenomenon, class, wherein solutes dissolve in solvents. Internal pressure, the presence of pressure. Okay, this one definitely applies naman, class, to gases. It usually applies to gas. Okay, then acid-base reactions. Ito yung sinasabi ko kayo sa inyo, di ba? That a weak acid will dissolve more in a base solvent, the basic solvent. Okay? Pero again, pero marami pang factors kasi, class, involved doon. Hindi lang ganun kasimple yung acid and base and acid. May mga factors pang involved dito, other factors. That's why we have a separate topic for this one. Pero the general gist is like that. Okay? An acid that combines with a base dissolves more, okay, because it becomes more water soluble. It actually becomes a salt. Naalala niyo ba how we make salts? How do we create salts? Salts, class, is a combination of an acid plus a base. Okay? That's how we make salts. Okay, I hope you still remember that in chem. Okay? This is through a process known as neutralization reaction. Okay? Diba, ang byproduct kasi ng neutralization, you still remember, so neutralization is an acid plus base, nag-neutralize. Ang byproduct niyan will always be a salt plus the liberation of water molecules. Okay, anyway, ba't ko ba yung sinasabi yan? Alam nyo na yan. Next one, ito, balik na tayo. Solubility in liquids. Solubility of gases in liquids. So sabi nga natin, class, one of the major factors affecting the solubility of your gas in a liquid would be, of course, pressure and temperature. Okay, yun two major factors. Salting out, class, hindi lang naman to limited sa gas, pwede rin naman to sa liquids or solids. Pero babanggitin ko na siya dito. Now, how does pressure affect solubility of gas? Sabi natin, the higher the pressure, the greater will be its solubility in gas, in solubility in liquid. All right? The greater the pressure, the higher is the solubility of gas in a liquid. So in a very dilute solution at a constant temperature, the concentration of the dissolved gas is usually proportional to the partial pressure of the gas above the solution at equilibrium. So the solubility of gas increases as you increase the pressure. Okay? And the gas would usually escape with violence when pressure above the solution is released. Okay, kaya nga diba yung Coke? Right? Yep. Sabi nagdala ako ng Coke para may example tayo. Pero anyway, so kasi once you open the Coke, diba yung psst, ganyan? Because you release the pressure that was confining the gas within the compartment. Okay, so that's why it's released violently. Now, class, sabi nga natin, diba, the solubility of gas, again, really depends on the pressure that is within the system. So gas volume is reduced, the pressure or concentration increases. So more collisions occur within the liquid surface. Now, ang sabi ko sa inyo, class, what defines this is the Henry's law. Okay, at pressures of few atmospheres or less, solubility of gas solute follows Henry's law. which states that the amount of solute gas dissolved in a solution is directly proportional to the amount of pressure above the solution. What do I mean by this? So say for example, class, Coke muna, Coke. Sa planta, ginagawa pa lang si Coke. Okay, so obviously class, Coke. Ayan, kung si Coke. Bukas pa yan, di ba? Lalagyan ko yan ngayon ng pure glucose fluid. Alam niyo bang glucose lang yun? Did you know, class, yung component ng Coke? Although may added mixtures pa yan, pero technically it's just glucose. It's just glucose water. So meaning, class, you get the same taste of Coke kung magtutunaw ka lang ng asukal sa tubig. Unahin mo yung asukal sa tubig, yun na yun, Coke na yun. Actually, ginawa nila kasi fructose to, in-invert nila yung sugar. Kaya siya nangitim. Okay? It's actually an inverted sugar. So it adds more sweetness to it. Pero class, technically, if you dissolve sugar in water, it's technically Coke na rin. What made Coke class different is the presence of fizz. Dissolved gases. So class, ano ang gagawin ko dito? Meron akong nozzle. May nozzle dyan that will introduce carbon dioxide. Okay? It's going to introduce carbon dioxide. And then class, that nozzle, sealed tight yan ha. Okay, sealed tight, which dissolves class yung carbon dioxide within it na. Okay? At the same time, just so you know ha, cool. Cold na nga lang. This is done under cold temperatures. Bakit ulit ginagawa siya under cold temperatures? To allow for? Bakit natin ginagawa to in cold temperatures?
To allow, yung gas.
Yes, very good. Okay? Para class, mas matunaw yung gas natin. Di ba sabi natin, solubility of gases usually happens kapag malamig ang temperature. So anyway, so yan class, ilalagay na ngayon yung carbon dioxide. Okay? Then class, take note, this is being done under pressure din at the same time. So as you put pressure, class, ito na nga yan, as you put pressure, ang tendency is, yung gas molecules, now, di-dissolve na ngayon within the liquid. As I increase the temperature, as I increase the pressure. At the same time, reduce temperature. Now, solubility of your gas class is simply expressed with the formula. Madali lang naman formula eh. Directly proportional lang siya. C equals Kp. C class refers to the solubility of your gas. Okay? Tapos ang K is Henry's law constant. It's a constant. Lahat ng molecules nating class or lahat ng gas molecules na ginagamit natin to dissolve in water has their constant. Halimbawa, carbon dioxide is 4.48 times 10 to the negative 5 molarity over millimeter of mercury or what do you call this? Pressure. Molarity over pressure. Okay, or mol over pressure. Okay? So yun siya. It's a constant class. So obviously, pag nagtatanong ako ng ganito, okay, I'll obviously class give you a list of Henry's law constants for the gases natin. Here's an example. This is just an example. Right? And then of course, class, P here stands for the partial pressure of gas. When I say partial pressure, halimbawa, obviously class, pag sinara ko na tong Coke na to, ay nilagyan ko na halimbawa ng carbon dioxide. Ito yung Coke bottle. Okay, yan. Pangit naman ang Coke bottle ko. Di na sexy. Okay, yan. So class, once na sinara ko na yan, obviously, andyan na yung carbon dioxide ko, dinissolve ko na, at the same time, it's sealed under pressure, right? It's sealed under pressure. So ibig sabihin, class, may pressure dito. There's a pressure inside, right? Okay, yung pressure na yan is dissolving my gas in my liquid. Now, class, kung ano man yung pressure na yan, that's called your partial pressure. Right? That's known as your partial pressure. Right? That's partial pressure. Okay, what's the pressure above the liquid? Above your solution. Okay, so ulitin ko lang ha, partial pressure is the pressure above the solution. Or sabihin natin yung liquid mo. Okay? What's the partial pressure? So obviously, class, if the soda bottle is sealed, saan mas mataas ang pressure? Sa loob yan or sa labas or sa atmospheric pressure natin? Okay, obviously, class, definitely. Okay, so thank you very much. So yung sa loob, class, ng bote natin, dyan mataas ang pressure. Okay? Now, class, sabihin natin, binuksan ko to. Ano na magiging partial pressure ng bote? Okay, halimbawa, binuksan ko. Ano magiging partial pressure ng Coke ko? Right? Once I open it.
Bababa na po.
Very good. Bababa. Up to what, up to how many atmospheres? It's going to start to equalize eh. Equalize with the room atmosphere or the environmental atmosphere, which is equal to
180 m.
Yeah, good. Kaya magiging partial pressure nito class, PP na lang is 1 atmosphere. Okay? Kaya tendency yung nag-build up the pressure dyan, lalabas. Kaya ganun. Alright? Okay. So class, again, papakita ko lang ulit. Ang formula natin class for Henry's law is simply multiply your Henry's constant. Okay, yung constant to the partial pressure. As simple as that. Ando yan, di ba? Okay, so it's nothing complicated, class. It's going to give you, tawag dito? It's going to give you an idea, class, of how many moles of the gas is dissolved per volume. Okay, yun usually na pinapakita niya dito. So, class, Henry's law constant for gas is usually expressed in moles per liter atmosphere. Okay? Or actually, class, if you look at this is actually molarity. Right? Mole over liter. This is molarity. Sulat ko na nga lang buo. Okay? That's molarity tapos multiplied to or the over pressure. So alam niyo naman class, ang expression natin for pressure can either be atmosphere, store, bar, ba? mmHg, ba? Okay, marami tayong units for pressure.
Kilopascal.
Kilopascals, pwede rin, tama. Okay, and so on and so forth. Okay? Okay. So let's have a sample problem here, class. Okay? So the partial pressure of carbon dioxide gas inside a bottle of cola is 4 atmospheres at 25 degrees Celsius. So ginawa niya to under room, regular room temp. Okay? So what is the solubility of carbon dioxide now? Okay, the Henry's constant for carbon dioxide dissolved in water is 3.3 times 10 to the negative 2 mole per liter atmosphere at 25 degrees Celsius. Now class, notice lang kayo na yung binigay ko sa inyo kasi na units is 4.48 times 10 to the negative 5. Pero this is molar per mmHg. Ito kasi, molar per atmosphere. Alright? Kaya expect nyo mas malaki yung number nito. Alright? Very good? Okay, so first things first. Ano mga kailangan kong ma-determine dito? Okay, so I need my molarity, obviously. Okay? Sabi natin, class, ano nga ba ang formula for molarity? Anyone? Okay, so molarity, sabi natin dito is simply moles per liter of solution. Okay? Okay. Now, asa may formula ko? Sorry, na-distract ako. May tumatawag kasi sa akin. Okay. So sabi natin, class, kailangan ko lang naman dito would be my gas constant. Right? Times, my molar gas constant times, tawag dito, my partial pressure. Right? So sorry, hindi ko na pala kailangan compute ang molarity ko kasi binigay na nga pala sa akin yung molar constant ko. So X to. So class, ang sabi natin, solubility natin, okay, C would be this one, simply this one. That's 3.3 times 10 to the negative 2 mole per liter atmosphere, ATM, multiplied to our partial pressure. And our partial pressure, class, is 4 atmospheres. Okay? And that would give me 3.3 10 exponent negative 2 times 4. Okay? The solubility, class, would be equal to 0.13. Ayun, very good. Thank you very much, Ms. Pioto, Conopio. That's 0.132. Anong use natin dito? It's going to be mole per liter. Alright? So that's how much moles per liter ang nagdi-dissolve of carbon dioxide at 25 degrees Celsius. So are we clear? Dali lang, di ba? Okay. Gusto ko pa kayo nang gawing complicated eh. Bigla ko na-realize, may molar constant na nga pala ako. Right? So are we good? Okay. So yun lang naman siya, class. So ito, here's the solution. So napakita ko lang. Okay? So Very good. Okay. Next, effects of temperature in terms of gas solubility. Sabi natin, as the temperature increases, solubility of most gases decreases. Kaya nga, as much as possible, if we want to dissolve our gas, we will have to do it under cold temperatures. This is due to the greater tendency of gas to expand. So property of expansion and pressure phenomenon requires that the pharmacist exercise caution opening containers of gaseous solutions in warm climates and under elevated temperatures. Right? So kung ba, pag magbubukas ka ng, alam mo namang ano, halimbawa, yung Coke, alam naman natin, halimbawa, naalog na. So usually gagawin ko dyan is, dahan-dahan lang. Release the pressure gently. Ayun, ganun. Okay? So dahan-dahan lang yung pagbukas. Para siya mag-explode in your face. Next one, class, is salting out effect. Familiar ba sa inyo yung term na to? Salting out? Not so much. Okay, now usually, class, when we say salting out, okay, lalo na kung ang solvent na ginamit natin dito, class, is water. Okay, especially if the solvent that we use is water. Now, class, salting out is the addition of small amounts of salt to causing your gas to escape. Okay, causing the gas that has been dissolved in the liquid to escape. Okay, what happens here? So isipin niyo lang ganito yung class, ha. Ibahin natin yung kulay, saglit lang. Okay. Say for example, class, sa gilid lang tayo, ha. These are your water molecules. Okay, these are the water molecules. Now, class, obviously, if I dissolve gases there, my gases starts to create bonds with the water molecule, right? Okay, it's going to create bonds. Yan. Is that a strong bond? Or just a weak bond? Yung bond na create ko between my water molecule and my gas molecule. Tandaan nyo, anong ginamit ko para mag-bind sila? High pressure, low temperature. Obviously, anong mabubuo kong klaseng bond? Baga, sinapilitan ko to. Yan ang mahirap, di ba? Minsan pag napilitan ka lang, the type of bond you create with someone, pag napilitan ka lang.
Dipole-induced dipole.
Good. Dipole-induced dipole. Or sabihin na lang natin kasi in general, it's van der Waals forces, right? It's going to be van der Waals forces. And van der Waals forces, class, are known to be weak bonds, right? Weak bonds. Now, kasi weak bond lang yan eh. Salting out effect. Obviously, anong dinagdag ko? I'm adding a salt. And you know, class, the type of bond that exists between a salt and a water molecule, right? Salt. Ito ngayon, dumating si salt. Ano sa tingin mo ang mangyayari sa bond na kinreate ni water kay gas? Kayo siya sasama?
Kay salt po.
Very good. Okay, kasi kasandaan yung weak force lang naman ang ginamit natin to create, para mag-dissolve si gas sa liquid. So, ibig sabihin, si gas ko kailangan mag-create ng bonds with my liquid or my water. Pero dahil nag-add ako, class, ng salt, okay, nag-add ako ng salt, ang tendency ngayon, ang affinity ngayon ni water, didikit siya kay salt. So, ano nangyari kay? Ayun, okay. Ano nangyari ngayon kay gas? Na-displace. Pinagpalit siya. Ouch, ang sakit. Okay? So, pinagpalit niya yung class si gas para kay sodium chloride. Kasi mas mataas ang affinity ni sodium chloride sa water. Kaya kasawag dito is salting out. So, ang nangyari ngayon, class, ano nangyari ngayon sa gas ko? My gas started to escape. Actually, kahit alugin ko nga lang yung tubig na yan, lalabas na yun. Okay? So, ang tawag dun, class, is salting out effect. Right? Are we good? Okay. So, class, it's another, salting out is another way of separating another solute sa liquid mo. Halimbawa, kunwari, class, nag-create ka ng solution. Kasi salting out, hindi lang naman applicable sa gas to. Pwede rin naman sa other types of solutes. Okay, halimbawa, gumawa ka ng solution containing something that only contains hydrogen bonds. Diba? Hydrogen bonds. Gusto mo silang paghiwalayin. Okay? Gusto mong paghiwalayin yung solute mo at saka yung solvent. Ang gagawin ko dyan, class, mag-add ako ng salt. Kasi lalo na pag ang solvent na ginamit ko is simply water. So pag ginawa ko yung class, pag nag-add ako ng salt dito, ang tendency is, yung water ko didikit sa salt. Tapos ngayon, class, ang mangyayari is, magpe-precipitate ngayon yung molecule na ginamit ko na nag-combine initially with water. Sorry, nag-gets nyo ba ako? Okay, baka may Okay, nag-gets ba, class? So, halimbawa, ito na lang. Gawa ako. Ito yung water. Okay, tapos nilagyan ko siya ng solute. I added a solute here. Tapos ang bond na kinreate ni solute na to at saka ng water is only hydrogen bonds, H bonds. Okay? Hydrogen bonds lang. Weak bonds. Huwag naman hydrogen, medyo mas malakas pa yan eh. Sabihin natin na van der Waals forces na lang. Malakas pa yung H bonds na yan eh. Okay, van der Waals bonds. Yun lang. So now class, halimbawa, sawa na ako sa solution na yan. Gusto ko na silang paghiwalayin. Okay? So para mapaghiwalay ko sila class, ano lang gagawin ko? Mag-add ako ng salt. By adding salt here class, I'm going to create what we call the salting out effect. Okay, wherein si water, imbis na makipag-bind pa sa solute na yon, okay, makipag-bind siya kay water, kay salt. So therefore class, si salt ngayon ang natutunaw sa water. Ano nangyari ngayon sa solute na to? Si solute na ito mag-start mag-precipitate. Alright? So therefore, pwede ko na ngayon siyang i-isolate. I don't know class kung magagawa niyo pa to sa pharmacognosy. Are you going to do salting out? Sinasalt out mo yung mga components ng inyong dahon. Right? Para ma-purify siya. This is actually one way of purifying your isolates. Or how to get isolates, technically. Okay? We do salting out. So are we good? Okay. So let's proceed. Solubility of liquids in liquids. So madali lang naman to eh. Okay? Ang sinasabi lang natin dito class would be 2 or more liquids are mixed together in the preparation of pharmaceutical solutions oftentimes. Now again, class, titignan mo lang naman ang polarity ng ating mga liquids na to. Are they both polar? If they are polar class or they are the same, or sabi nga natin, like dissolves like, kung polar yan, obviously dapat polar din ang solvent mo. Kung non-polar ang solute, non-polar din dapat ang solvent. Halimbawa, alcohol which is polar, okay, it's definitely soluble class in water. So therefore, we are able to create hydroalcoholic solutions. Volatile oils. Okay, volatile oils, just so you know, class is polar by nature. Okay, so hence we can combine it with water. We are now able to create aromatic waters. Okay, obviously, class, volatile oils, which is polar, can also be dissolved in a polar solvent such as alcohol. Okay, wherein we create a spirit, or what we call, elixirs. Ether, on the other hand, class, okay, medyo nasa lower spectrum na siya ng water solubility. So therefore, gagamit na tayo ng alcohol. Kasi ether class does not mix with water. So you know, mahirap i-mix yan. Not unless you combine alcohol and water. Okay, gagawa ka ng co-solvent. Pwede ngayon mag-mix si ether doon. Pero class, ether and alcohol are soluble with each other. Okay, and if you combine ether and alcohol, you create what we call a collodion. Right? So fixed oils naman are examples of which are lotions and sprays, medicated oils. Okay? So ang categories class ng liquid-liquid system natin or liquid-liquid solubility, dalawa lang naman yan eh. Dalawa lang sabihin na dyan. Is it completely miscible or partially miscible? Okay, ano ibig sabihin class pag sinabi natin miscibility? Miscibility simply refers to the mutual solubility of the components in a liquid-liquid system. Miscibility class is the term that we use para masabi natin na natutunaw ang isang tubig, ang isang liquid in another liquid. Question. If I combine oil and water, okay, most of the time, naghihiwalay yan. Are they miscible or immiscible? This is oil.
Immiscible.
Good. Very good. Okay, so oil and water class, the combination of both is an immiscible combination. Okay, pero class, if I start adding here other co-solvents like alcohol, dagdagan ko pa halimbawa ng acetone or di kaya glycerin, pwede ko lang matunaw si oil dito or ga-add ako ng surfactant, which makes it partially miscible. Okay? Now class, again, pag sabi natin complete miscible, ibig sabihin talagang tunaw. Tunaw na tunaw sila sa isa't isa. Highly soluble. So 2 or more liquids class when mixed together and mixed in all proportion, tawag na doon is complete miscibility. Normally, this is a combination between a polar and a semi-polar solvent. So alcohol and water, glycerin, alcohol, acetone, okay, it creates a completely miscible system. Non-polar solvents such as benzene and chloroform are also completely miscible with each other as long as, kasi the reason for that class is because they are both non-polar. Partial miscibility class usually happens when the mutual solubilities of partially miscible liquids are influenced by temperature. Halimbawa, okay, like say for example, water plus ether or water plus phenol. Okay, Normally, class, pag pinagsama ko si water at saka si ether, di ba sabi ko sa inyo kanina, hindi soluble si ether sa water? No. Okay? Normally, class, it creates a two-phase system. Although, hindi ganun ka, hindi ganun siya ka-defined, pero makikita mo talaga, class, andito si ether, lulutang si ether, nasa ilalim si water. Pag pinagsama ko silang dalawa. Okay? However, I can actually create a partially miscible system between water and ether. How? I'll manipulate other factors affecting solubility, such as, of course, a factor there would be temperature. Okay? Ano gagawin ko sa temperature ko? Painitin ko yan. Okay, once class na painit ko yan, makikita mo class, maghahalo na ngayon si ether at saka si water. Because I was able to manipulate another factor affecting solubility, which is temperature. Technically, class, ano to eh, non-polar si ether, polar si water. Sabi natin, like dissolves like, di ba? And then, hindi sila magkapareho, dapat hindi sila matutunaw. But, I manipulated another factor, which is temperature, to allow it to be partially miscible. It may not be completely miscible, class, ha? Not completely miscible, but at least partially miscible. It still gives me a homogeneous mixture. Okay, pag sabi ko homogeneous, completely dispersed. Right? As long as I keep that temperature hot. Okay? Pero kasi pag malamig na yung temperature na yan, obviously, maghihiwalay ulit yan. Okay? And lastly, class, solubility of solids in liquids, which is what we usually use naman in pharmacy, right? Okay, so class, madali lang naman to. It's the most important type of pharmaceutical solutions. Nagtutunaw tayo ng powders in liquids. Halimbawa. So for ideal solutions class, the solubility of solids in liquids may depend on temperature, melting point of the solid, molar heat of fusion. Na hindi ko pa pala na-discuss sa inyo. Hindi ko pa na-record ba yan. Okay, magala. I'm gonna do it soon. Okay, magala. Mga next sessions natin, hindi pa naman ganun ka-related sa solids.